good manufacturing practice. Operator must be trained to carry out the documentation procedures. The next one is record must be made manually or electronically during the manufacturing process. A record of manufacturing including distribution that enable complete history of batches to be traced must be trained in comprehensively and accessibly form. So any distribution of product must be minimize any risks to their qualities. So that is why record must be made manually or electronically for the manufacturing in the form of different manufacturing processes. And the last point, the complaint about market product must be examined. The causes of quality defect must be investigated, or you can say that is analysis of defect, and the appropriate measure must be taken in respect to the defective product and to prevent the recursion. So these are the basic principles which include in case of good manufacturing practices. Moving to the next one. So these are the basic. These are the last one. These guidelines provide minimum requirement of a manufacturer must meet to assure their product are consistently high quality for batch to batch for their intended use. The last one, the rule that govern each industry may differ significantly. However, the main purpose of good manufacturing process is always to prevent harm or occurring to the end users. Going to next one. So these are the next one, the requirement of good assembly line. So before starting this particular topic, we must know about the assembly lines. So what are the assembly lines? That is the arrangement of machines, equipments, and worker in which way the work pass from operation to operation in direct line until the product is assembled. The next point is that the process is for turning out a finished product into a mechanical efficient manner. So that is why we have arranged your layout in such a manner that everybody should be get attached to the workstations, and there is less, you can say that is most optimized way of transportation of raw material from one workstation to other workstations. And the next one, a manufacturing tool is first made popularly by Henry Ford in this good manufacturing practices in the sector of automobiles. And this principle of assemble lines for each worker is assigned on a very specific tasks, which he or she simply repeat, and then the process move to the next worker who does his work task until the task is completed and the product is made. It is way to mass produce good qualities and efficiently. The all worker do not have to be human or robotic workers can make up with assembly line as well. So also a particular images the past and present scenario of assembly lines. So as you know, in case of air conditioned companies, there are few multinational company, even if Indian company are assembling those things. In the past, only peoples are get attached to the assembly lines, and due to conversion of on-skill into semi-skill and semi-skill into highly skilled, it took some times. But in case of present scenario, due to eliminate the effect of human error, they directly employed robots for assemble works in the same lines. So if you take the companies like GRE in the form of assemble lines, in case of air condition manufacturing or assemble, in that case, it is the only one company across the world, or you can say is the best company across Asia or Southeast Asia. They directly focus on making robots for their own companies initially, but later on, due to high demand from customer point in case of assemble lines, they export this type of robot in case of air conditioning assembly to other companies like Samsung, like Hitachi, like your Onida, and other company which is directly concerned with air conditioning. Going to the next one. So in case of assemble line productions, few things or you can say few benefits and drawbacks should be considered. Some are quoted here. The first one is specialization of labor and capital. So in case of assemble line, as far as concerned with the specialization of labor and capitals, an assemble line is a sequence of worker and machines that each perform a set of specific tasks on a particular product that is moved to closer to a finished form. So in case of primary benefit of this particular assembly lines is that they allow worker and machines to specialize at a performing specific tasks. So suppose you hire different level of worker, for example, in case of unskilled, semi-skilled, and highly skilled. So you assign the job according to their skills. That is the concept of specialization of labor and capital. The next is large scale assembly lines can allow for mass production of goods that would be possible if the product were made from start to finish by a single worker. The next point is a high conductivity of mass production can also result in case of lower per unit produced that other manufacturing methods. So these are the points belong to your specialization of labors. The next point is uniform product. So this is the another benefit of using assemble lines in the manufacturing process, that a regimented production process help ensure a uniform product. That means a team should be perform the production process and help to ensure uniform product. You can say in other words, the products made by assemble lines are not likely to exhibit much variation. If worker created entire good stretch, his product might be significantly different from a good produced by another employees. So it should be vary from specialization to specialization and vary from skill to skill. The next is initial cost. So when assembles line are potentially reduce the total cost of product per unit, they can have a high initial cost. So as you know, in case of mass industrializations, the initial cost is very much higher side. The assemble lines are require significant amount of space to operate, and renting factory floor space can be expensive. So for land acquisitions, then uh, you can say that is establishment of new industries. You can say the setup of new machine, arrangement of subfloors. That should be very much high expensive. The next point, in addition to assemble lines, often make use large specialization machines that can be expensive to purchase and difficult for small business to finance. This is the one drawback as far as concerned with line productions. Then last point, and assemble lines need to increase productivity and sales enough to cover the initial cost to be considered as a sound investment. So whenever you invest a huge amount of capitals for establishing subfloors, land, and set of new machines, so in that regard, you have to maximize your sales that you can cover the initial investment cost. Next one. The next one is the classification of manufacturing cells. So as you know, the manufacturing cell classified into three different environment. The first one is classical manufacturing cells. The second one is virtual manufacturing cells, and the third one is dynamic manufacturing cells. We will discuss one by one. The first one is classical manufacturing cells. In case of classical manufacturing cell, it is otherwise known your traditional manufacturing cell or manufacturing system, in which it is directly machine intensive. The most of the work content of operation is done by machines, not the workers. You can take the best example in case of CNC machines, computer numerical control machines. The worker role is usually limited to loading and unloading the workpiece. Once cell are formed, it is costly to rearrange the machine. As a result, frequent redesign is not an option. So in that CNC machines, what will happen? The numerical control machines, for loading and unloading activities should be done by the worker level only, and each cells are a particular cell is formed. It is costly to rearrange the machine for frequent, or equation that is the continuous redesign of the particular product. The next part is the design of a classical cell need to be robust to handle challenge in product and demand. And the last one is if changes in product mix or demand are significant, then it is necessary to redesign the particular cellular system. So suppose a huge amount of demand in the form of new product mix is occurred. In that case, you have to directly go for redesign the whole cell of manufacturing systems. The next one is here the example of classical manufacturing cells. Here I quoted the example of lithium-ion battery manufacturing. So you see, so these are the process flow diagram is given starting from the slurry preparations, then coating of and drying in case of dry cell battery, then candling, then cutting of electrodes, then cell assemble, and finally electrolyte fillings and formation. So these are the process flow starting from the slurry preparation to the finished product in the form of dry cell battery in the category of lithium-ion battery. In the bottom figure you show, if you put the whole thing line assembly, or you can say that is the shape of layout should be that much of flexible that few people, only two to three number of, or four to five number of people should be get attached to the maximum number of workstations. That is the concept of classical manufacturing systems. The next part is that virtual manufacturing cells. So in case of virtual manufacturing, is used in a system where it is infeasible to rearrange the machine or workstation, because machine and workstation are relatively large in size. Each type of machine is spread throughout the facilities, and machines are grouped into cell on assignment level and not necessarily physically levels. In a virtual cell, the redesign of cells and product families are done with relative ease. As a facility grow to the match the increase in demand, the efficiency of these virtual cell will increase, and it might be possible to form the classical cell. The next point is the virtual manufacturing often uses just-in-time approach to manufacturing process, and there is little room for work in progress storage. That if you go to the next one, the rearrangement of cell is done with relative ease because the layout of the facility is not physically configured. There are also some case study related to virtual manufacturing in the upcoming slide. And the last part is material handling cost is associated with virtual cell are high. If multiple machine of one type are needed, they will be located in different areas of facilities, and this could lead to confusion. The forming virtual cell will help to reduce the confusion among planner and material handler. So here the case. So as you see in the figure, the first one is computer aided modeling is there, and there are three peoples are involved in case of computer aided modeling in case of product design and development, and they are directly attached to the intelligence virtually by manufacturing cells. The next part is that, as you know, in case of virtual manufacturing process, there are more heavy machines are there that should not be moved from one places to other places or one facility to other facilities. And here, three machine work facilities are attached. One is plant, other is other machines, and the bottom is other machine. They combine with the intelligent virtual manufacturing cell. So if you combine three number of designer and three number of machine located in different places, that can be make a particular virtual cell, and this is the biggest concept. You can say that is the most important concept behind virtual manufacturing, and it is applicable especially in cases of Mahindra and Mahindra, where before launching the Mahindra Scorpio, you should know that is the first sports utility vehicle in case of India. So due to rapid demand in case of that vehicles, the company started virtual manufacturing process. They assigned different countries. For example, in case of Egypt for body, uh, for you can say that is for engine and different component to other countries which is directly or indirectly involved in case of manufacturing. The intelligent manufacturing cell will form in the Nasi plant, and that Nasi plant is coordinating starting from the CAD design department, the manufacturing department, the assembly department, and collaboratively they form the virtual manufacturing cell to produce that SUV vehicle in the form of Scorpio. The next part is that dynamic manufacturing cells. So in case of dynamic manufacturing cells, uh, as you know, in case of it is used in that kind of environment where product demand is unstable and the workstation is facility. Workstation in the facility can be easily rearranged. So this type of environment often exists in the firm that do mostly subcontracting works. So it is applicable to the large scale industries like steel plant, where most of the work done through the dynamic manufacturing cells, especially in case of furnaces where liquid metal should be poured and formed in the form of steels. So where the uh, furnace lining work, shop floor cleaning work are directly done through the subcontracting works or assigned by the subcontractors also. So this type of environment is very labor intensive and it is easier to move machine than the virtual manufacturing cell and as compared to the classical manufacturing cell. So here the examples, as you know, as you see in the particular figure, there are two number of uh, cell is there which contain three type of machine and each machine contain different type of machine and due to labor intensive one can easily move the workstation to other workstation or even if the machine should be shifted to, you can say that is machine should be shifted to or mobilized to one place to other place due to labor intensive. Next point is in case of dynamic manufacturing cells the inter-cell transfer occur in the form of machine movement, not the product movement. So here in case of dynamic manufacturing cell only the machine should be transported or mobilized from one place to other place, not the product move. It is possible to eliminate the excess material handling cost with this appropriate. The best example you can take in case of your construction work, construction of bridges, construction of roads, more type of or more heavy machine would be shifted from one place to other place. And only one movement is taking place instead of several batches of product being moved throughout a facilities. So in dynamic production environment, a multi-period planning horizon is considered in which the product mix and or part demand rate in each period may be different, such as seasonal product demand. So in that case, it assumes the product mix and part demand is constant for the entire production horizons. And the last part, in case of dynamic manufacturing or cell manufacturing system, it implicate to reconfiguration of manufacturing cell at each period. So basically, the reconfiguration involves swapping existing machine between cell called machine relocation should be done. Or you can add new machines to your workstations, which contains or which includes machine replication also, and removing existing machine from the cell. If a machine is found defective, you can remove and add new machine. That is the concept behind dynamic manufacturing cell because, as I told, so these are very much labor intensive. So as far as concerned with the classical classification of manufacturing cell, in case of your classical, the machine should not be moved. But in case of your virtual manufacturing, you can be work from a different location. The facility should be placed in a different location, and that should be virtually connected to the manufacturing cell. But in case of due to you can say that is labor intensive of your dynamic cell, you can directly mobilize the machine from one place to other place. The next one is computerized allocation of facility techniques, or it is known as craft techniques. So particularly it is otherwise known as the craft algorithm. The craft algorithm was originally developed by Armour and the Bufa, and it is improvement of particular algorithm which is directly concerned with manufacturing layout. It starts with the initial layout and improve the layout by interchanging the department pairwise so that the transportation cost is minimum. So in this regard, I will give the best example in case of large industries where a huge amount of raw material should be transported from one place to other place. So whenever it reach inside the organizations, the raw material should be transported through the automated guide vehicles to the concerned department. And the concerned department is processing the material and again transported to the inbound storage. Then inbound storage to the quality check, then quality check to dispatch department. So due to this initial layout, it improves the interchanging department. For example, in case of packaging department, so the packaging department is equipped with more number of loading and unloading equipments. So due to that, loading and unloading equipments, there are more number of loading and unloading equipment is available in that department, and that should be pair wise, and due to that pair it directly impact on the reduce the cost of transportations. The next is the algorithm continues until the further interchange are possible to reduce the transportation cost. So as a result, given by the craft algorithm, it is not optimum in terms of minimum cost of transportation, but the result will be good and close to the optimum in majority of applications. So hence the craft is mainly heuristic algorithm, and so users of efficient heuristic like craft is inevitable for such problems. So what are the basic requirement for the craft? The first one is initial layout, then flow data and load summary, cost per unit distance, the total number of departments, fixed department number of such department, location of those department. The next is area of department. The next one, these are the basic requirement for your craft algorithm. The next is craft procedure. The step of craft procedures or algorithm are summarized below. If you go to the first one, that is input level. So in case of input level, the few point which is mentioned below is included. First one is number of department. The second is number of interchangeable department. The third one is initial layout, and the fourth one is cost matrix. The next one is flow matrix, that is load summary, and the next one is area of department should be considered. The next part, that is step number 2, compute the centroid of department in present layout. The next is form a distance matrix using centroid. The next is given the data on flow, distance on cost, and compute the total handling cost of department. Handling cost of present layout, not department. Then step number 5, find all possible pair-wise interchange of department based on the common border or equal areas criteria. So for each possibility, the interchange and the corresponding centroid and compute the approximate cost. The next one is find the pair of department corresponding to the minimum handling cost among all possible pair of interchange. So due to that interchange, or you can say that is distance matrix, a particular centroid location would be identified through the layout. And due to that centroid, the raw material should be kept on that particular place, and that should be moved according to the requirement of production activities. That is the concept
सर
behind craft reduction. Yes, yes, yes.
तो सेंट्रोइड का मतलब क्या है?
Centered means by application of craft analysis, before you implementing the particular layout, the centered position of that organization should be identified, where each department can minimize their distance. For example, in case of fire and safety department should be placed on centered location by using of distance matrix, so that whenever any kind of casualty or difficulty occur inside the organization, everybody can get attached and controlled with the fire and safety department. That is the concept of centroid. Clear?
मतलब क्या सेंटर में होना चाहिए क्या?
हाँ, center में exactly. Suppose your waste disposal department is far away from that department. Clear? So that is why in case of safety they are pair with a sub department of safety department. एक छोटा सा डिपार्टमेंट रहता है जहाँ वो लोग वेस्ट डिस्पोजल एरिया में स्टैब्लिश करते हैं. दैट इज द कॉन्सेप्ट बिहाइंड क्राफ्ट. बट इन केस ऑफ जनरल ऑर्गेनाइजेशंस, क्लियर, if you take the example of healthcare sector, in case of privatized hospitals, clear, why the pharmacy department will be placed or your laboratory department is placed as far as concerned in the centroid locations, that every department starting from the surgery, starting from the medicines or other department is directly concerned with that particular department due to the central location, and it is happened due to the distance matrix. That is the concept behind it. Clear?
ठीक है सर. हाँ.
Okay. The next is layout planning and analysis. So in this procedure, or this is a procedure of making the layout of plant or making improvement in existing layout with the help of number of tools and techniques. So also some tools and techniques already given in the slide, that is flow chart, the process flow chart, machine data cards, then template and scale models. So before starting those things, in this particular layout planning and analysis, a plan showing the position of machines, flow of work, material handling devices, and material handling devices, etc., is prepared to scale on drawing sheet or floor. The previous, so there are various tools are used in this particular techniques. So as I told, the first one is flow process chart, process flow diagrams, then machine data cards, the template and scale model. We will discuss one by one. So in the flow process chart, a graphic representation of sequence of operations. Then next one is transportation, inspection, delay and storage occurring during manufacturing. So this given information regarding the distance moved and time required for various activities such as transportation and delay or in case of inspection, etc. So this chart helps to determine the hidden efficiency in the process that may suggest a rearrangement of layout. This also point out the elimination of unnecessary movement and processes. So if you go to the most branded company in case of paper industries, the, like JK Paper in case of Raigada, this flow chart process will be displayed in the main gate. So whenever the employees starting from the top level, middle level, and bottom level enter inside the organizations, they initially noted those things, the flow chart process, and its flow chart process uh, directly represent the different sequences, transportations, inspection, delay, as well as the storage, and even if the production capacity and total production per day should be displayed on that particular board. The next part is that if you go to the flow diagram, this is the sequence. This is the typical example of flow diagram. As you see in the particular figure, the flow process chart, which include different operations, then movement, then inspection, delay, storage, and number of distance should be passed, and that should be displayed uh, in in each department and sub department also. Going to the next one, process flow diagram. So if you go to the process flow diagram, it is a diagram of building plan representing graphically the movement of material on the drawing. With its help, proper material handling arrangement can be made. It indicates long material haul and back tracking of present layout, which thereby help in improving and the layout. So going to the next one, I'll show the process flow diagram. So here is the typical process flow diagram for power plant. So as you know, in case of thermal power plant, which is vastly present in our state, like the place like Talcher, like the place like Jashpur Industrial Belt, even if the place like Jharsuguda in the Industrial Belt, where more amount of thermal power plant are already established. In that case, basically coal are used in case of a boiler, that is already given in case of steam boiler, and steam is generated, it is directly fed into the turbine. When turbine rotate, the generator which produce electricity, and the rest amount of condensed water is directly go for the cooling, and again cooling tower to the feed pump through it reach to the boiler. That is the concept of a flow diagram in case of your power plant, basically the thermal power plant. Going to the next one, machine data card. So this card gives complete specification of each machine to be installed, such as output capacities, the foundation, the space needed, the method of operation, maintenance, handling device of machine, etc. Then it is not, it is simply a display card regarding the specification of machines, which is displayed in each workstation, which contain various type of machines. I'll show that one. So in the next figures, you see this computer display, which provide the basic specification of CNC machines in a particular companies that contain various data. So what type of data? The specifications, the loading or loading, the maintenance equipments required, and the specifications and other maintenance related data should be written on the thing, and how to maintain, how to make smooth operation in that particular machine, that should be displayed on machine data cards. Going to next one. The next one is template. So after studying the flow chart process or you can say that process chart or process flow diagram and machine data card. The floor plan is prepared by fixing the area occupied by each item to be erected in the shop. So this floor plan is prepared certainly scale saying 1 centimeter square is equal to 1 meter square. So now from the thick sheet of paper or cardboard piece are cut. These are known as template to represent the various items which are to be housed in the plant and are to be placed on the floor as suitable places. So whenever you start a new company, according to the slope floor, you have to arrange by using this type of template for the availability of spore as far as concerned with manufacturing activities. So these templates are so arranged to give the best layout that change, if any, the required are made before making actual layout drawing. So if you made any kind of changes, you must concern or you can take the reference from the actual layout drawing. Next one. So here the scale models, sorry, template one. So as you see in that particular figure, there are 7 number of machines, including fasted, including fire and safety cylinders, including conveyor belt is there. I know one side is exist, one side is. So according to that thing, the template should be given the 7 number of machines according to their process flow diagram, a process flow chart, and the machine data. So you have to arrange whenever you shuffle the machine or you can rearrange the machine, you must refer the actual layout of this particular organization. The next one is scale models. It is an improvement over the template method in this tool. Instead of template, use three-dimensional. The scale model is made. So it is, I just repeat that one. It is an improvement over the template method. In this tool, instead of template, use three-dimensional scale model is used. So this model may be wood or metal, and when you use on a layout a series of additional informations about the height, about the projected part of the machines are to be obtained. So this is similar to your child doll house. You can say that is you have already involved in case of science exhibitions where scale model are displayed by a number of students. So this technique is useful for complex layout requiring initially huge investment. So due to that thing, also some scale model. So is the typical scale model of your thermal power plant. So from the right corner, you have seen this type of chimney in a day-to-day life, and this and the uh, you can say that is uh, left side. It contains cooling towers. Then the boiler house is there. The blue color tall building is known as boiler house, and all the concerned department are arranged through the making different scale and height. So whenever the company faces any difficulty, they can be likely to be changed as per the authentication of top level of management regarding to take the reference from the scale model. Okay, so that's all for today. If you have any doubt, you can ask. Any doubt?
No, sir.
Okay,
No,
thank you.
sir.
I will.
No, sir.
Okay, thank you. I will send the PPT. Clear?
Sure, sir.
Sir.
Okay, thank you.
Thank you,
Thank
sir.
you.